Okay, we're in section 34 and we're still on the fundamental theorem. I'll go through the examples. It's not an extensively long section, but for some students, it's complicated. All right, here's the deal. You got to study, you got to follow the examples that we're giving you. And then, of course, after you do the study and you follow the examples, you got to try on your own. And again, we've been saying this repetitively for a long time now. And I always say this is something you should have learned very early in your careers. And that's a problem. A lot of students have not learned that early in their careers. And what happens to them is they get lost and they don't realize why they're lost all the time. There's a fundamental procedure that needs to be followed for study. You need to understand what's being presented in the lecture. You need to understand the examples the teachers are giving you. Then you need to reinforce with examples. As you move forward to a four-year institution now, you're going to be left alone. What I mean by that, most of your learning will be taking place not through lecture material, but through a textbook. I would recommend that that's something you want to catch on to as well. The textbook is going to be your salvation. Read the textbook. Read the text before you go to lectures. When you go to lectures, you might be confused, even if you've read the textbook, but you'll be more clear about what the expectations are. Go back to the textbooks. Textbooks nowadays have tremendous number of examples in it. What's the problem with textbook? They're overwhelmingly long nowadays. They're super long. Historically, if you looked at a calculus book, it didn't have, like the number of pages I have now. A calculus book now is well over 1,000 pages in it, right? You go back 20 years ago, it might have been 500 pages. Go back 100 years ago, you might have been looking at about 150 pages. It really has changed a great deal. And what is that? It's just getting overwhelmed with examples, all right? So let me go to the whiteboard and let me just do that share for you. And we'll do the examples. As I do the examples, it's me basically just reiterating what we said in the problems up to this point and the lectures, but I'm kind of looking at it in example number one. And if I were looking at this guy over here, I think I could do the question without too much problem. And I want to tell you what I mean by that. They tell me that this big G of X is a function, and that function is defined as an integration. I think I could do the integration. Let me put this down for you. And what do you get? Well, let's take a look. You would get t cubed over 3 minus 2t. I'm not going to put the constant down, but the limits integration over here are 1 to x. We have a key to check, and we'll certainly answer their questions. What would you get over here? X cubed over 3 minus 2x minus, I got to do the lower limit now. That's 1/3 minus 2. I'm going to clean it up a little bit. It's going to be x cubed over 3 minus 2x. And then what do you get? 1/3 minus 2 is minus 5/3. Minus a minus 5/3 is plus 5/3. By the way, I am not claiming that's their question. All right. Let's see what their questions are, though. The first question is g of 1. Well, there's two ways I could do that. I could write down the function g, evaluate at 1. Well, I just did it, right? What would that give you? 1/3 minus 2 plus 5/3. I'm just plugging in 1, by the way. 6/3, which is 2, and 2, 0. I could also do the integration. So g1, what's that going to be? 1 to 1. Again, if you don't remember, the integration is over here. T squared minus 2. What I know about this one, it starts at 1, stops at 1. The function is defined there. The base length is 0. The area is 0. We're getting the same answer. Let's keep going. They want to do g prime of 1. Well, you know what I need there? I guess I need to know what g prime is. I think I can do that. That's going to be x squared. I'm looking at this, by the way, minus 2. So what's g prime of 1? 1 minus 2, which is minus 1. You know what? I think I have another way of doing that. I want to point out what I mean by that. I have the integration. G of x is equal 1 to x, t squared minus 2t. I'm sorry, minus 2 dt. I could write down g prime very easy by using the fundamental theorem. The g prime of x is going to be x squared minus 2. And G prime, I'm using the fundamental theorem of 1, would be 1 minus 2, which is minus 1, right? Both ways, it's an answer. All right, so, I got this one, I got that one, make sure of that. I did, yeah, I think I did. What's G prime of 2? Well, I think I could do that now. G prime of 2 would be 4 minus 2, which is 2. And I could also do it up here, and it's still going to give me 2. So I'm going to put 2 down there. That's not bad. And it said, what the function g of x? And I think we did that. And that's right over here. Let's see if we did it right, though. X cubed over 3 minus 2x. Not bad. It was an easy question, right? A confidence builder, so to speak. Let's go to the next question. This is not a confidence builder for a lot of students. And I'm going to point out, there are many ways to do it. And a lot of times people they really are confused by my answers. And we're not trying to confuse you. And don't feel alone, by the way. I've had instructors come by with my notes and say, how did you get that particular answer? Let me go through it for you. All right. So looking at it, I'm kind of looking at it, and I want to see if I can do it in a variety of different ways. All right. So let me put this over here. This is going to be x squared, x4, and that's going to be the root. By the way, what about x squared and x4? They're always non-negative numbers. Whatever x is, it's always a non-negative number. And what would you get over here? It's t to the 1/2 dt. So I'm going to say, no matter what x's they're giving me, this is defined for those x's. They could be negative x's, positive x's, they could be 0. It's defined. So what do you get over here? Well, how do you integrate that? I guess I have to add 1 to the exponent, right? And what would that give me? T to the 3/2. I would divide by 3/2 or multiply by reciprocal 2/3. Limits of integration, x squared, x4. Let's write this down. This is 2/3. I'm going to evaluate the upper limit, which can be x4 to the 3/2. We'll do that later. Minus x squared to the 3/2. By the way, I find this to be 100% acceptable. If that's your answer, put it on a box. But I want to do some simplifications over here. What do you get? 2/3. Let's see. 4 times 3/2. Well, 2 goes into 4. 2 times 3 is 6. That's not so tricky. This one's tricky, though. I'm not trying to trick anyone. I want to write down what it says to do, though. The square root of x squared cubed. All right. It's the square root of x cubed. I'm sorry, the square root of x squared cubed. This is actually the absolute value of x cubed, which if you were to cube that, you would get x squared absolute value of x. Let me do it a little bit differently for you. And I'm going to write this one instead. I'm going to write down x squared to the 3/2, right? Which would be x6 to the 1/2 power. If you wrote that down over there, again, it might look strange to you, but what would you get? Let's take a look at that. It's the square root of x4 times x squared. The square root of x4 is just x squared. But again, the square root of x squared is actually the absolute value of x. That's why we're getting that. Let's look at the key, though. I'm saying that's one way to do it. And I think I might have made a mistake somewhere. Oh, I'm sorry. They asked me to differentiate it. And did I do that? I'm sorry, I did the integration. They didn't ask for that. They asked for me to differentiate. I got to write that down. That was unproductive as far as I'm concerned. And I apologize. We're not going to lose sight of it, though. I got to differentiate. Let's write this down. So I'm going to differentiate now. So I'm going to differentiate d dx, the integral x squared, x4 t to the 1/2 dt. Well, I just did that, didn't I? So I'm going to differentiate I'm sorry, it's not ddt, I'm sorry, dx. Sorry about that. ddx. Well, I just went through a bunch of work, didn't I? And I found out that was 2/3 x4 3/2 minus x squared to the 3/2. All right, let's take a look and let me go through it with you. Oh boy, it's gonna be a lot of work, isn't it? So 2/3 times the derivative of this guy on the inside. Well, it's gonna be 3/2 x to the 4. I take away 1 from 3/2, which would be 1/2, times the derivative of the inside, which is 4x cubed. Minus, don't panic yet. Let me see if I wrote down that right. Yeah, 3/2 x squared to the 1/2 times 2x. All right, let's take a look. I'm going to multiply it out. And let's see, 2/3 times 3/2 is 1. x4 to the 1/2 power is just x squared. Then you can get 4. I'm seeing that x cubed. I'll take care of that later. That's still going to be 1. And then I'm going to get, well, the square root of x squared is the absolute value of x. And then I get a 2x there. Let's write that down. So what do you get? 4x5 minus 2x absolute value of x. All right, let's take a look at the answer key and see if we did a good job. Now, I make mistakes sometimes. And I see the 4x5 minus 2x minus root x. All right, I want to do it a little differently, though, by the way. So why do you want to do it differently? I like the way you did it there. The thing is, we want to give you options, all right? We want to give you options. So I'm going to point out that whatever this thing is over here, all right, like if I'm writing something down, I'll write this one over here. If I have a function f of t going from x squared to x4, this would be some antiderivative, right? T evaluated x squared x4. Let me write that down for you. So x squared to x4 f of t dt is some antiderivative evaluated at x4 minus some antiderivative evaluated at x squared. All right. So let's see if we can differentiate. And I got to be honest with you. It's the left side that's so much trouble for me. I'll just write it down though. It looks like a nightmare to me. What do I know though? I know the derivative of that big F is a little f. So it's going to be little f evaluated at x4 times the derivative of the inside, which is 4x cubed, minus the derivative of that big F, which is little f, of x squared, times the derivative of the inside, which is 2x. Let me write that down. I think it's pretty easy to do. It's going to be 4x cubed f of x4 minus 2x little f of x squared. Well, you know what? This is related to what we just did over here. What's the f? It's the root of t. So this is the f of t. Let's write that down now. So what do you get? 4x cubed, the root of x4, we'll simplify it later, minus 2x, the root of x squared. 4x cubed, the root of x4 is just x squared, minus 2x. Well, the root of x squared, again, you learned this in Math 119, is the absolute value of x. So what do you have here? 4x5 minus 2x absolute value of x. Let's take a look at the answer key, see how we did. And And I'm seeing it again, same thing. Someone says, I like this method or like that method. You need to find a method that works for you. Now here comes my problem, the next problem. Getting the antiderivative is going to kill me. I can't do it. Right. So what I'm going to tell you over here is I'll write this down for you. So u to the 3u of this awful looking nightmare to me. By the way, you'll learn how to do that in Math 122. But right now I'm going to say there's some antiderivative, evaluate 3u minus, I don't know what the antiderivative is, evaluate u. What am I going to do? I'm going to differentiate both sides for you and write this down. D, du, that's what they want me to come up with, of the left side, which looks like a nightmare to me. Is going to be equal to, well, what's the derivative of the big F? It's the little f. So it's going to be f of 3u times the derivative of the inside, which is 3, minus, what's the big F's derivative? Little f of u, and the derivative inside is 1. So I'm not going to put that down. What's the little f? This is the little f. Let's write it down. 3 root. What if I plug in 3u there? What would I get? 9u squared plus 1 minus f of u. And what's f of u? It's just simply u squared plus 1. Let's look at the key and see how we did. And again, I can't say there's enough time. You want to look at the key. And did I miscopy the problem? You know what? I think I miscopied. And I apologize for that. It's not u, it's minus u. That's just my bad eyesight, I think. Let me erase. And someone says, why do you erase it? Why don't you just simply correct it? I got to erase it. I made a mistake. All right, let's go back over it again. And I'll be better the second time through it. All right, let's write this over here. So it's going to be, let's write this down. So it's not u, it's minus u. My mistake. And what do you get over here? I'm going to say some big F. I have no idea what it is. Again, if you take calculus 2, you'll find that out. I'm going to differentiate both sides with respect to u. And again, the left side really is a killer for me. The right side's easy. And I'll differentiate the right side. And that's going to be d du f 3u minus f of minus u. And what do you get over there? Well, the big F, when you differentiate little f of 3u times 3, whoops. And then it's going to be minus little f, minus u times minus 1. That's the derivative of the inside. All right, let's see if we can do that. And again, I'm going to go over here. You have to understand what the f is. This is the f in the problem. So f of x is actually just the root of x squared plus 1. So this guy over here, let me put him over here, is equal to, let's see, 3. And 3u squared would be 9u squared plus 1. And what do you get now? You get plus, because minus and minus is a plus. And then when you do plug in minus u, what do you get? U squared plus 1. That's final answer. Again, it's right over here for you. All right. See if we got that right. Yeah, we did okay. All right, let's talk about that connection again. And this is like the oil and water connection. You know, it's like an interface between two barriers over here. And the barrier for a lot of students is they look at this thing almost as if it's a waste of time, because they say, the only thing I really need to do in life, and this is not all students, some people don't have to do homework. They think they just show up to an exam and they're going to do well. And it never really works out well for them. You got to catch on to this. All right, so what I'm going to say over here, the connection between these two is the study department. So what does study mean? You know, maybe looking back over the notes, maybe watching lectures again, maybe reading a textbook, maybe trying to push yourself forward, trying to reach for something that might be beyond your grasp at this point, but you want to get there. All right, does it happen? Yeah, for the people that study this, it requires time though. Put the time in before you do the homework. But after you do the study time, you study the material that we've given you, homework should be easy, very easy, including the WebAssign homework. All right. You got to put the study in first. A lot of people do it backwards. They try to do WebAssign or homework or God forbid, try to do an exam with doing little to no work. That does not pay off. All right, please put the study time in. Thank you.